Hi, in this video, we're going to be talking about inductive reasoning. Inductive reasoning means we're going to use logic to look for patterns in what's going on. This is not super accurate, but it's just trying to get an idea based on what's happened before, what would happen next. So for example, here, I've got 4, then 8, then 16, and 32, and I'm looking for some kind of a pattern of how we're moving from one spot to the next. I could think about 4 plus 4, that equals 8. So that works if I'm just like adding 4. But if I do 8 plus 4, that's not 16. So that doesn't quite work. So I got to think about something else. Well, I could also do 4 times 2, and that's going to be 8. And then if I check the next one, 8 times 2, oh, that's 16. And we can see that continuing. This is times 2, times 2, times 2. If your first pattern doesn't work, try something else. So the next two numbers in our sequence should be 32 times another 2, which is 64, and then 64 times another 2, which is 128. So that's our pattern for the first one. In the next one, we could look for some sort of pattern as we're moving from one to the other. So this one seems to be adding 0.04, and then we're adding 0.05. So that the adding trick doesn't quite work. Multiplying doesn't quite work because we're multiplying by 5, then by 2, then by something else. So that's not quite working. So there's something else that's happening. Well, hey, I know some of these values. That first thing is a penny. And then the second thing is a nickel. A nickel is 5 cents. Penny 0.01. And then we've got a dime. That's 10 cents, a quarter, and then a dollar. So then the thing after a dollar is like a $2 bill, so $2. And then our thing after that would be $5. But we're not quite sure if they're going to count a $2 bill in this pattern or not because it's not a common currency. So we don't know for sure that's what's going on, but we've got some sort of pattern where we're thinking about, okay, penny, nickel, dime, quarter. Okay, that seems to be working so far. This next sequence is like based on like movies. So like Fast and the Furious was the first Fast and the Furious movie, and then after that they made another movie, Too Fast, Too Furious. Then they made Tokyo Drift was the movie after that one. Then they made the Fast Five or Fast and Furious for the let's see, that's the fourth one. Fast Five was the one after that. And the one after that, they decided to go back to just straight numbers. So Fast and Furious 6. Uh, but then there's also movies that kind of like sneak into that sequence if you're thinking more chronologically in what's going on in the movie and not necessarily a release date. So that sequence, like it seems to be that's the order of the movies, but as they release more movies, they might fill in some gaps in between those movies. So it's not perfectly clear. But that's our best guess of what we think is happening. So when we're making a best guess, what we're making is something called a conjecture. A conjecture is like it seems to make sense, but we don't know for sure that it's going to continue in that pattern. So if we look at this sequence right here, this seems to be squares. So like 1 squared, 2 squared, 9 squared, 16 squared. 16 is 4 squared, and then 25. So that seems to be squares, but there could be something down the line where that changes. But based on what we have so far, it does seem to be squares. It wouldn't make sense to say, oh, well, the difference between right here is 9, so just go based on that. No, we have to look at the whole sequence and see what's happening. So let's try to make some conjectures down here. We're looking at what the sum of the first 6 positive even numbers would be. So I've kind of written out what's going on so far. So if we have one even number, so that's 2. The second two even numbers is 2 and 4. If we add those together, we get 6. 2, 4, and 6 are the first 3 even numbers. That adds up to 12. These ones add up to 20. These ones add up to 30. And what we're looking for is to make some conjecture about what would happen if we did the first 6 even numbers. Now we can see over here with this little shortcut, it seems like, hey, that's first sum is 1 times 2, that's 2. And then the next sum, that's 2 times 3, that's 6. We could just add over here, but this multiplication works too. So we got 3 and 4 is 12. Let's see if that keeps going. So if we do 4 times 5, hey, that's 20. That's the same as adding up all these numbers. And if we add on one more and kind of tick on a number here, 5 times 6, that seems to be 30. So we think this sum should be, let's see, so it's going to be the first 6 even numbers. So that should be 6 times 7 because we did the first 1, 2, 3, 4, 5 right here. The next thing in the sequence should be 42. We could check that by adding up all those numbers. So here's our first 6 even numbers. So let's see, that's 6 plus 14 plus 22. So this is the same as 20 plus 22. Hey, that worked. Cool. So we made a guess. This is our guess. And our guess worked. So this is our conjecture there. Now, we could try to add up all the first 30 positive numbers, but I don't want to do that. I want to use a guess, a conjecture again. So if the first 6 was 6 times 7, the first 30 should be 30 times 31. And so whatever that would be, it seems to always be the number of terms. It's always n times n plus 1, the number of terms we've got in that sequence. So I got to do 30 times 31. That's 930. I spliced it out, me calculating it. But 30 times 31 is 930. So that should be the sum of the first 30 positive numbers. But again, this is just a guess. We don't know for sure, but that's our guess at what's going on. I didn't actually add up the first 30 positive numbers, and I'm not asking you to either. We're just making a guess on what's happening so far. We could do the same with the first 100. That would be 100 times 101 because we're taking 100 and then the next number after it because that's what we did with 6. We did 6 and the number after 6. So if we did the sum of the first 100 numbers, that would be this number, 10,100. I'm not going to actually add up all the first 100 positive numbers. This is just a guess, a conjecture about what we think is going on. And that's it for our video. This inductive reasoning is just trying to make a guess about what's happened so far and what we think might happen next based on that pattern. Thanks for watching. Bye-bye.